Hey, what's going on, everyone? Homework assignment 36. Today's objective, I could find square roots and I could find cube roots. We'll talk about what both of those mean. Square roots you've probably heard more of than cube roots, but we'll talk about both of them. So, few vocabulary words we have here. Or vocabulary, yeah, we'll call them words. Starting off with perfect squares. So perfect squares are rational numbers whose square root is a whole number. So, for example, we say that 25 is a perfect square because the square root of 25 is 5. So we call that little sign the square root sign or the radical sign, but we're going to see that on the next page. So the square root of 25 is 5, meaning that 5 times 5 is 25. All right. The square root of 25 is 5 because 5 times 5 is 25. So I could even add that in here. So square root, so I'll say it even here. Square root of 25 is equal to 5 times, is equal to 5, take that back, because, that's a D, what am I doing? Because 5 times 5 equals 25. All right. So square root of 1, the square root is one of two equal factors of a number, meaning one of two numbers that I can multiply by themselves to get another number. Negative numbers do not have real square roots. So if we see an example that asks you to find the square root of, let's say, negative 25, we cannot find that because it is not a real number. Okay, we can't find that right now because it's not a real number. We're only sticking with real numbers. Yes, there are numbers that are not real, but we can talk about that in class. So the radical sign is that symbol that we see right there. So it looks like a little check mark almost. A little check mark with a little flat end, a horizontal line at the top. It's used to indicate a non-negative square root. So right here, if I ask you what is the square root of 36, we should know that the square root of 36 is 6, or we're going to know that the square root of 36 is 6. If I asked you what the negative square root, notice how the negative is outside of the square root. Negative square root of 36, it is negative 6. And if I asked you for this little symbol means plus or minus, meaning the positive or negative square root of 36, then the positive or negative square root of 36 would just be basically these two things combined is going to be 6 or negative 6. So the plus or minus square root of 36 is 6 or negative 6. But we won't see too much of this plus or minus until we get into like quadratic equations in algebra. All right. So along with the squares, we also have cubes. So we have something called a perfect cube, which is a number that is the cube of an integer. So 27 is a perfect cube because the cube root, notice how our radical sign has a little 3 on the side of it, or on top of it, better yet, or in it. The cube root of 27 is 3, meaning 3 times 3 times 3 equals 27. So when we see cubes, we think of the value of 3, meaning that there are 3, in this case 3 threes. The cube root is one of 3 equal factors of a number. Now, cube roots, remember what I said about we can't have negative square roots? Well, we can have negative cube roots. The cube root of a positive number is positive. The cube root of 0 is 0. And the cube root of a negative number is negative. Okay, a lot of information that's coming at you, but we'll talk about all of it slowly. Okay, and we'll see some examples of that as we go forward. So I am asking you to copy down this list and to refer back to this list as we are working. It's good to have, and eventually I'll say it's good to memorize. So your squares from 1 to 25 are very good to memorize. I usually know my squares from 1 to 15, maybe 16, and then I know a few of them as we go here. But it is definitely important to know at least those first few squares, and it's good to know these other squares as well. So please copy these down, have them in your notebook. We're going to be referring back to them. In addition, I'd like you to also copy down our perfect cubes, okay? Goes from 1 to 13. I think that's a good enough list. We usually don't deal with cubes that are much higher than that unless you get to higher level math and then you start studying cubes and perfect cubes and stuff like that. All right, so please copy that down as well. All right, so let's go ahead and let's do some examples. So we're being asked to find each square root. And what we can do to find each square root is we can use that list of squares and square roots to help us out. So first one asks us for the square root of 9. So I'm going to go right here, and I notice that the square root of 9, I can find it right here. 3 squared is 9. Therefore, the square root of 9 has to be 3. Okay, so the square root of 9 has to be 3. All right, we can do the same thing with the other values. Square root of the negative square root, of 64. If I go back to my list, I'll find out that if I see 64, then the value associated with 64 is going to be 8. So the square root of 64 is 8. Therefore, the negative square root of 64 is negative 8. And C asks us for the square root of negative 81. Can we find the square root of negative 81? We cannot. I'm going to say that it's not applicable because there are no real numbers. So not a real number. All right, let's keep going. Being able to estimate square roots to the nearest integer. And all of this really being done without a calculator. We could always double check with a calculator, but all of this really could be done without a calculator. So the square root of 33 is not a perfect square, but we can estimate it to the nearest integer. So I know that the square root of 33 is somewhere between, and let's find some perfect squares that it's between. So I know that the square root of 33 is between the square root of 25 and let's see, 5. Oh, and the square root of 36. All right, and we ask ourselves, which value is this closer to? Is the square root of 33 closer to the square root of 25 or the square root of 26? And it seems like it is closer to the square root of 36. So the square root of 33 is approximately, this is a symbol we use for approximately, is approximately equal to 6. All right. Same thing with our problem below. So we have the negative square root of 129. So that one is between the negative square root of, let's see, 121. So I'm picking my perfect squares here. And the square root, negative square root of, let's see, 121 and 144. And which one is it closer to? Seems to be closer to the negative square root of 121. So therefore, the negative square root of 129 is approximately equal to negative 11. Okay, so again, I'm doing all of this without a calculator. You can do all of this using this list to kind of help you out. So notice I saw 121. 129 is between 121 and 144. So that means it had to be between 11 and 12. Therefore, I figured it was 11 because it's closer to 129. All right, moving forward, find each cube root. And I can use my cube list to help me out with this as well. So let's see, that was the 343 right here. The cube root of 343 is 7. Again, notice that little 3 that's up here. That tells us that we're dealing with a cube root. The cube root of negative 729. So cube roots, we can have negatives. Okay, we can have negatives for cube roots. Now let's go back and see. Let's find my list. 729. Right here. So therefore, the cube root of negative 729 is a negative 3. Negative 9, I'm sorry. All right, same deal here. We're going to estimate, just like we did before. So estimate our cubes to the nearest integer. So I have the cube root of 83. So I know that that's between 2 cubes. So the cube root of 64. And let's see if we could find what the other one is. So 83 is between the cube root of 64 and the cube root of 125. Excuse me. And the cube root of 83 seems to be closer to the cube root of 64. So 83 seems to be closer to 64 than it is to 125. Therefore, it's approximately equal to 4. All right. Then we have the cube root of negative 2024. So let's go back. That's a big one. That one I haven't memorized, but let's check it out. 2024. So that seems to be between these values right here. Cube root of 1728 and 2197. So 1728 and 2197. And I think we said that they were negative. Therefore, it seems to be closer to. Ooh, which one is it closer to? It seems to be closer to this one right here, because it would have been about 300 units away from that first one. So it's got to be closer to the second one. Therefore, it is equal to approximately equal to 13. Oh, went too far. And there we go, cubes and squares. I'm going to go to one more video because I don't think I can move over, but I'm just going to show you, if you don't have a scientific calculator at home, I'm going to show you a good one that you can use if you are finding cubes and squares and whatnot and how to really manipulate it. All right, check out those practice problems as well.